Hey everyone, my name is Ryan Jenkins. Like I said there, I'll be talking about the multi-cluster networking, a network operator we built to do this. A little bit about EU projects, AC3 part of there. But just a little bit about me. So my name is Ryan Jenkins. I'm an associate software engineer. I've been working at Red Hat. It'll be 2 years in September, which is crazy. Part of an EU project called AC3. We based in Waterford, Ireland. Waterford, Ireland is kind of like an EU hub for projects. We currently have 4 there at the minute. So AC3, Code2Co, Green Dot, and P2 Code. I think this is like the last talk, so pretty good idea to have the best for last. I think a few people might have had a few lemonades last night, so I'll keep it short. Yeah, so this is our consortium for the project. So these are all the big dogs kind of doing all the work. So we have Red Hat here, IBM, UBTech, Eurocom are actually the leaders of the project. So they're the coordinators, and they're based in Spain, I think. So network programmability. So I'm just going to quickly talk about our role in the project. And that's just the title. It's quite a broad statement. It's like a big, loud statement that you kind of don't really know how to describe. But just to give it one line, so it's to proactively and reactively configure the network to meet AI predicted requirements and solve unpredicted anomalies. So this work is kind of split into 2 different sections. So proactive and reactive. Proactive is basically like the CRUD element, so the create, read, update, and delete of links in the network. And then the reactive is kind of like when you send traffic at it, how the network adapts and how it works. So like if one site gets overloaded, create a new link to another one, see how that goes. And basically go on and on and on. So the operator architecture here. So you can see, so it's actually a technology-agnostic operator. So we can see here, we have 3 different technologies, Skupper, Submariner, and SD-WAN. Right now we're configured with Skupper only, but we're looking to add more in the future. So we have a northbound API here, which is basically our CRD. So when you want to add a new application, you just send it up, whether it's an Nginx, could be anything, and then that'll get added to the CRD. You then deploy it, and it'll get exposed across the network using Skupper. We have a reactive piece here. I'll talk about that later on. And then monitoring, basically we have just, so we can kind of see when a site gets overloaded, when to do that change. So when to create that new link or delete it even. And then we have 2 data centers here. So like these are just 2 clusters, for example, based in different locations in the world. So I'll talk just about the reactive piece a bit more. I didn't have a full slide on it because I know probably wouldn't have enough time, but I just said I'd just talk about it quickly. So the model we used was the follow the sun model. So basically, we want to send traffic. So this is for the reactive piece. We want to send traffic to sites with, like, say, higher sun density. So if you go to Las Vegas, like, obviously higher sun, higher solar energy, that will process data faster for that site. So that's kind of why we want to always be sending traffic as opposed to a site that could be located in the North Pole, for instance. So it's a bit slow. So our network programmability tools, like I said, we're configured with Skupper right now. We have Submariner, Kepler, and everyone. Skupper is application-based networking, so so one application will speak to another on a different network, on the same network, just on a different site. Submariner is strictly, it's not application, it's just network itself. Kepler is how we're monitoring the energy usage. And then everyone, which is an open source version of SD-WAN, is basically the same kind of thing we're doing with Skupper, it's just non-Kubernetes. Challenges in multi-cluster networking. So we had a cluster isolation security. Security is always an issue for kind of networking. Network policies and firewall rules. So when one cluster is speaking to another, there's always going to be rules in place. So like my cluster will be different to your cluster for the rules that I set to it. Latency and reliability. In networking, of course, latency is always a big issue. And reliability, making sure the site stays up. Multi-cluster context switching. So like I said before, if we were doing a piece of work in one cluster, switching to another cluster, we kind of do work step by step in each cluster. So that's kind of how we're doing our multi-cluster context switching. So the operator workflow, we have a reconcile loop that kicks off. We fetch our custom resource, so that's in the CRD. That's the CRD. We access cluster configurations, so we have a config map. We have a shared kubeconfig map. Yeah, I said that right. Shared kubeconfig map, basically containing the API keys for clusters that we put up. And basically, every time we want to switch, we use a get, and then that's kind of how it's just switching between clusters. So yeah, managing Skupper config, I kind of mentioned that. Copy and update secrets. So a secret, a link is created by having a secret on one site, and then you basically copy that link over. So I copy that secret over to a different site, same link, same token, but that's just how we're talking to each other. And then annotate deployments for Skupper, so that's how we're exposing applications across the network. So I'm going to show you a quick demo here. Please. Great. Or just the workflow, how it works. Right, so give a quick prerequisite. So this is a Skupper UI. This site here is where the operator is deployed. So it's just one site on one cluster. And I think this guy is also, he's also on the same cluster. And SK3 here is on the second cluster. So that's the Skupper UI. So I'm just going to show you, briefly go around. I'll show you the services. So those are the applications. So I think Nginx and Rabbit are currently up right now. That's just the topology. So that's I zoomed in there. It's called Skupper site. It's a config map. So our prerequisite for this work is we have a Skupper operator living on every cluster that there's a site on. And once this guy comes up, all these guys get generated. So Skupper internal, Skupper network status, Skupper ASL, SASL config, and Skupper services. And that's kind of the kickoff, and that's done in the reconcile loop. Here's our secret for that site. That's the SK1 token. And now switching to the other cluster, same thing again. So it's just that config map, and then you'll see a secret here. So what I'm going to do here is I'm going to quickly show what it's like to create a new link. So here's our namespace. It's called SK4. This is in the second cluster, by the way. So you can see here, there's no pods here. There's nothing. And once I get added to the CRD in a sec, SK3 is living there. Add SK4. Just deploy that there. Configured. And then you can see all the Skupper pods coming up in Skupper resources. And going back to our UI, you can see the new link was created to SK4 there. Yeah, so there's 2 clusters involved here, and we will look to add a third in the future. Yeah, so that's kind of it. What the heck? Yeah, thank you. Any questions? Class. Thanks, guys.